Hi guys, so previously we have already learned esters, okay? So when we talk about the alcohols and the carboxylic acids, I already did an introduction on the esters. So how to name esters, how to draw, right? So technically this part is just like a revision, okay? So there's one thing that I would like to highlight is this, okay? So when we write it in the molecular formula, right, in this form, right? So this part here is the functional group, okay, which is this one, the carboxylate group. So when we write it in the molecular formula, okay, it is understood that the front part, if I cut it in the middle here, all right, this part belongs to the acid, okay, whereas the one at the back belongs to the alcohol. Okay, so if they give you any molecular formula of the esters, how to know which part is the acid, which part is the alcohol? Okay, if looking at the structure is easy, right? You just cut in the middle here. Okay, but when it's in molecular formula, remember, please do not cut at the wrong part. All right, you're supposed to cut in the middle here. And normally the front part is the acid and the back part is the alcohol. So, and then remember the naming, the alcohol name must be in front, the acid name must be at the back. Okay, so that is it. All right, so carboxylic group, remember this is the functional group. Okay, the C double bond O, O. Now another mistake that normally I see students making when they draw the structural formula for esters is that because here is COO, so when they draw, they tend to draw it like this, COO, and then they draw it like this. Technically, they just direct translate the molecular formula into a structural formula. Now, you need to remember this is wrong. Okay, it's both oxygens are bonded to one carbon and not like this, right? I've even seen some, they do it like this. C double bond O and then the single bond O here. This is also wrong. Okay, so be very careful when you draw the structural formula. Okay, you need to remember that the oxygens are bonded to one carbon atom. All right, it's not oxygen bonded to oxygen. No. Okay, all right, and then this one I already mentioned. You need to know the name of the reaction. Okay, esterification, and then you need to know the catalyst. Okay, so whenever you write the what they call a chemical reaction, you must always include the catalyst. Okay, so in this chapter, from alkene up until esters, all right, you have a lot of chemical reactions that where some requires you to use the catalyst. So you must write the name of the catalyst. Okay, all right, so let's do another revision again. Okay, so butanoic acid. Okay, so remember 4 carbon acid. All right, so if it's 4 carbon acid, so how do we draw it? Okay, I'm just going to draw out the what they call, I'm just going to write out the chemical formula. All right, 4 carbon. So here will be C3H7 COOH. Okay, remember butanoic acid, 4 carbon including this carbon here. All right, if you look at the general formula for your acids, okay, this part, okay, CnH2n plus 1. So here 3, this one will become 7. Okay, so do not forget that. All right, pentanol, 5 carbon alcohol. Okay, so you have C5, okay, H11, OH. Okay, remember the general formula for your alcohol. Okay, now remember the acid will provide the hydroxyl, alcohol will provide the hydrogen. So technically, you are just taking this part, combining to this part. So what happens is you are going to get, okay, so this one is the acid, right? So C3, C3H7CO, and then the alcohol part, O, and then this part, C5H11. Okay, so that is how you write the molecular formula. Okay, now what if I draw out the structural formula? Okay, so methanoic acid, 1 carbon. Okay, so 1 carbon, double bond O, OH, H, this is methanoic acid. Okay, ethanol, 2 carbons. Alright, okay, H. Okay, put it alcohol here. Alright, I put the hydroxyl group at the left side because it's easier to see, right? You can see the what they call combination. Okay, hydroxyl and the hydrogen from the hydroxyl from the acid, hydrogen from the alcohol. So you remove this part, then just bring this whole thing combined to this part, to the acid part. So I have C double bond O, K H, and then the alcohol comes in there. Okay, H2. Alright, so okay, so this is the ester. Okay, so the name of the ester, alright, so alcohol name in front, so ethanol will become ethyl. So this one is ethyl, and then methanoic acid will become methanoate. Okay, so that is how you what they call write the structural formula or chemical formula. Okay, propanol. Alright, propanol. So in this case here, the alcohol is at the front. So remember, there's no fixed what they call format in saying that the reactants, the acid must be in front. No such thing. Alright, you just need to know at the final product here, okay, the esters, right? The alcohol name must be in front, the acid name must be at the back. So propanol is C3H7OH. Okay, pentanoic acid. So 5 carbon acid. So here C4H9COOH. Okay, 4 carbons plus 1 here, so it's 5 carbons. Alright, so let me just use another different color so it will be more clear for you. C4H9COOH. Okay, so remember, combine, remove the OH. So C4H9CO, OH gone, H gone here, O, and then C3H7. Okay, that is how you combine your alcohol and also your carboxylic acids. Okay, so this one, the name will be propanol will become propyl, and then pentanoic acid will become pentanoate. Okay, right, another one, butanoic acid. Okay, so this one maybe I'll just use a structural formula. 1, 2, 3, 4. Okay, H. Right, fill in all your hydrogens. Okay, ethanol. Okay, wrong spelling, definitely. Okay, 2 carbon alcohol. Alright, so normally we like to put this one here so it's easier to see, right? Okay, then easier to see here and here. Remove these two, combine straight away. Okay, so 4 carbons, 1, 2, 3, 4, double bond O. Okay, so when you draw the structural formula, it's going to take some time, alright, but be patient. Okay, don't draw the wrong structural formula. Okay, better safe than sorry, right? Slow and steady, no problem. Okay, so here the name will be ethanol will become ethyl. Okay, and then butanoic acid will become butanoate. Right? So basically that is how we write the molecular formula and also draw out the structural formula for the chemical reaction for esterification. Okay, remember this reaction is called esterification to produce ester. You mix alcohol and carboxylic acids. Alright, physical properties. This one very important. They always ask this in your exam. Right, remember they have a special one which is the sweet smell. Okay, and then previously I did mention less dense than water. So water will be at the bottom, the ester will be at the top. Alright, and then you have colorless liquid. Okay, normally you see colorless liquid. Okay, very volatile. Okay, meaning they evaporate very easily. Alright, since you are covalent compound, remember covalent compound, they are insoluble in water. Okay, so these are the few physical properties that you need to know for your esters. Alright, users. Okay, so you need to be careful in your SPM. Okay, normally nowadays the trend of questions is that they are going to use examples in your daily life. So they are going to focus more on the uses of the ester, and then from there onwards they are going to construct their question. So in other words, meaning they will give you a picture, and then they are going to say maybe contains a flavoring of a certain type of ester, so on and so forth. Alright, so questions nowadays will be focused a lot on your application. Okay, so you need to know, identify when they give you the picture or the diagram, it's regarding which topic or subtopic, right? Especially in organic compounds, a lot of application. Okay, now for esters, all right, a lot of the uses of esters is in food, okay, flavoring, and also in your cosmetic industry. All right, so these are a few examples of esters that you use in your daily life. Okay, this one, haha, Fruity Loop. Okay, breakfast. All right, you can see here you have orange, green, you have grape. So technically, your Fruity Loop here, okay, the flavor comes from the ester. All right, so let's say for example the orange, right? This is orange. Okay, the ester name or the flavoring that gives you the orange flavor is what we call octyl ethanoate. Okay, so this one gives you the orange flavor. Okay, and then based on the name, as you can see, octyl meaning it comes from the 10 carbon alcohol, octanol, and then you react with the acid, okay, the ethanoic acid. Alright, so remember, okay, your application in esters a lot, okay, food coloring, perfumes. Okay, perfume we use a lot of esters because of the sweet smell, right? Okay, flavorings, adhesives, sometimes in glue also you will see esters inside. Okay, solvents, all right, the girls, you like your nail polish and everything, right? So you will have esters in your nail polish as well. Okay, so many applications of your esters, but they focus more on food flavorings and also in cosmetic products. Okay, because of their properties, the sweet smell. All right. So technically for esters, okay, we have what they call natural source and also synthetic. All right. So a lot of your maybe your soft drinks, okay, they are using synthetic flavors. So synthetic flavors meaning they are actually using the esters. Okay, so for example, pineapple. So which ester will give you the pineapple? Now, when they give you the molecular formula, you need to be able to write out the name. Okay, so remember, where should we cut? Okay, in the middle here. Alright, so after you cut here, front part is the acid. Okay, so front part is the acid, and then the back part is the alcohol. So the name, this is a 2-carbon alcohol, right? So it's ethanol. So the front will become ethyl. And then the acid name, okay, here 3 carbons, right? But don't forget to add the carbon here. So in total, it's 4 carbons. So 4 carbon acid is butanoic acid, right? So it becomes butanoate. Oops, my god, my writing. Right, butanoate. Okay. Right, okay, again, here. Cut here. Okay, front part, back part, alcohol, 1 carbon alcohol. So it's methanol. So we change it into methyl. Okay, and then the acid, 4 carbon acid, same thing, so it's butanoate. Okay, last one. All right, this is a 5 carbon alcohol. Okay, so it's pentanol. So change into pentyl. Okay, pentyl, pentyl, and then here it's 2 carbon acid. So it's ethanoic acid. We change to ethanoate. All right. So technically, these are the ester names for the flavors. Okay. So in other words, if you have access to lab, all right, if you can try this at home, who knows, right? Maybe your home has, maybe you're doing I don't know what kind of business, all right. But if you have the chemicals, for example, you have the pentanol, or the easiest to get is ethanol, right? Because it's alcohol, right? All these are alcohol, but the easiest one you can get is ethanol. Okay, so ethanol, and then if you have the butanoic acid, you mix them together, all right, you should be able to get your pineapple flavor or the pineapple taste. Okay, so for your exam, you need to know the names of for all these natural sources. Okay, the ester name. All right, you need to roughly know. Okay, so that is the uses of esters. Okay, oh, there's one more here. Production of polyester. Right, polyester is your fiber, your shirts. Okay, so some shirts, they are using polyester as the material. So especially the one that is rather difficult to iron, it feels like your paper money. Okay, your plastic money. Okay, there's a similar what you call texture there. All right, polyesters. Okay, and then another thing you're going to learn later on is your fats. Okay, basically your fats are actually esters. All right, if you learn bio, right, your fats is the triglycerides. Okay, basically your triglycerides is kind of esters. So we are using ester to produce soup. Okay, so this one you'll learn in the next part. Okay, so technically that is it for your esters. Okay, so this is the whole picture or the main idea of this particular chapter. All right, your carbon compounds. Okay, you need to know how to convert from one carbon compound to another. All right, meaning if you start from alkene, you need to know how to convert it into alcohol, and then from the alcohol, how do you convert it into the acid, and then how do you change it into an ester. You must know the whole story from start to finish. Okay, basically you're linking everything that you have learned. So it's very, very important that you are very, what you call, sure of all the chemical reactions, right? So at this part here, they've already summarized the chemical reactions for each homologous series. Okay, remember when we say homologous series, we are referring to the names here: alkene, alcohol, carboxylic acid, esters. So in total, you have 5 homologous series. Okay, and then you have the functional group. Alkene functional group is double bond. Alcohol functional group is OH. Acid functional group is the COOH. And then the ester is the COO. Right, you must remember the functional group. Okay, so conversion, how to convert from one carbon compound to another. All right, so alkene. Okay, we will start from alkene. Okay, so alkene, if I want to change it into alkene, it's hydrogenation. Remember, hydrogenation meaning we add hydrogens in. So if I add hydrogens in, you will change from an alkene to alkane. Now for an alkane, if you want to convert it into alkene, the process is called cracking. Now this process can only be done in the industrial scale. Okay, and it's what do you call very difficult because you need a lot of heat energy. All right. So just know that if you are converting from alkene to alkene, the process is called cracking. Now from alkene to alcohol, okay, it's called hydration. Remember, hydration meaning you add in water, okay, steam, okay, and then from alcohol, if I change back to alkene, is dehydration. Okay, and then from alcohol, if I want to change to carboxylic acid, oxidation, meaning I add in oxygen. All right, and then if you mix these two, it's called esterification. Okay, and then there's one more, whereby you also need to know if I can combine alcohol and acid to become an ester, I can also separate an ester to become alcohol and carboxylic acid. So if it's the other way around, it's called hydrolysis. Okay, so hydrolysis, alright, okay, is when I convert or I separate the ester to become the alcohol and carboxylic acid. Okay, that is the name of the process. Okay, so you need to know how to form esters and how to break esters. So technically, the product you will get is the alcohol and the carboxylic acids. Okay, hydrolysis. So remember that, right? Ester, when they undergo hydrolysis, they separate to form alcohol and carboxylic acids. Okay, so technically, this is the whole picture, right? So you need to know how to convert from one carbon compound to another. Basically, you need to know all the chemical reactions for all homologous series. Okay, so that is why this chapter is not really difficult, just that it's a lot, okay, a lot of information to process. Okay, now this is the summary. Okay, important things. All right. So combustion, okay, of alkane and alkene produce different amount of soot. Remember, they produce different amount of black smoke. Okay, so the one that produces more black smoke is the alkene. Okay, because the percentage of carbon is higher. Alright, so combustion is used to differentiate between alkane and alkene. Alright, now next, okay, addition reaction. Okay, you need to know addition reaction. All alkenes undergo addition reaction. Okay, alkene, they undergo substitution reaction. Okay, so addition reaction of alkene with bromine water changes, remember, brown to colorless. Okay, you must remember this because this is a test to differentiate alkene and also alkene. Alright, okay, so another test to differentiate alkane and alkene is using bromine water. Okay, remember you have three ways to differentiate alkane and alkene: combustion, reaction with halogens, and another one is with the oxidizing agent or the potassium permanganate, potassium manganate. Alright, so remember I already mentioned the color change is important. Okay, so potassium manganate is purple color. Okay, purple color of acidified potassium manganate to colorless. Okay, alkene does not have this reaction. Only alkene will undergo this reaction. So once again, okay, this one can be used to differentiate. Sorry. Alright, differentiate. Okay, so potassium manganate or potassium dichromate. If it's potassium dichromate, it's from orange to green. Okay, so you need to remember the color change for the oxidizing agents. Alright, hydrogenation. Okay, remember this one is alkene, addition reaction. Okay, all alkenes undergo addition reaction. Remember we have 5 different addition reaction. So hydrogenation, you change alkene to alkane. Okay, and then again, addition reaction with water changes alkene to alcohol. Okay, and then for the alcohol part, alright, so remember if it's what they call oxidation. Okay, oxidation of alcohol, change alcohol to carboxylic acid. Okay, you must know the conversion. How can I convert one form to another? Alright, and then if I want to reverse, okay, dehydration changes alcohol to alkene. Okay, so these are the important things, alright, and then esterification is between alcohol and carboxylic acids. Okay, so this is a summary for the homologous series. Okay, Alright, so there's a notation here which says that all this, the one with the hash, is done in industrial scale, right? Cracking, hydration, whereas the others you can do it in the lab. Okay, fermentation. Remember, if you want to change the glucose to alcohol, fermentation. Okay, you put in yeast, right? So this is the whole story of the carbon compound. Okay, very very important. Okay, normally the question, they don't just focus on one carbon compound. They are going to link everything in one whole question. All right. So that is it for the uh, first part of your non-hydrocarbons and also your hydrocarbons. Okay, your homologous series. All right. So next, I'm going to show you an example of questions on how they will ask questions on this particular topic, your carbon compound. Okay, so they always like to do this. They put it as unknown, and then they give you the molecular formula. Okay, so your job is to identify the homologous series for each molecular formula given. So how do we identify is by looking at the functional group if they have one. All right, now in this case, C4H8, no oxygen, right? So this one is hydrocarbon. So it's either alkane or alkene. So you need to remember the general formula for your alkane and alkene. Okay, so CnH2n plus 2. This is alkene, whereas for alkene is CnH2n. Alright, so this is alkane, this is alkene. Okay, so you need to remember the general formula. Now in this case, okay, C4H8, okay, meaning is this one. It's an alkene. Alright, so let's look at the first question. What is meant by unsaturated hydrocarbon? Okay, remember another name for alkene is unsaturated. If it's alkane, it's saturated. So when I ask you for the definition of unsaturated hydrocarbon, two very important things that you need to mention. Okay, so when you write your answer, you will say compound that contains okay, this one very important, must have in your answer, carbon and hydrogen only. This is the first thing that you must have. Okay, with at least one double bond, okay, between atoms, between carbon atoms. Okay, so the important thing is that you must have this, contains carbon and hydrogen only. Okay, this word is better to put in this word in your answer, and then with at least one double bond. Okay, you must have these two answers, these two key points in your sentences. Okay, so which of the organic compound is unsaturated? So it's P, right? Okay, this one, OH is alcohol. This COOH is carboxylic acid. Okay, so that is how we identify the homologous series. See, they will ask this. State the homologous series for P and Q. So P is alkene. Oops. Alright, so P is alkene. Okay, Q, we have the OH, the hydroxyl group. So it's alcohol. Okay, so next. Okay, they are going to go into the chemical reaction. Okay, compound P can be produced from Q. So meaning that we are producing what we call alkene from alcohol. Alright, so P from Q, meaning you're changing from the alcohol to alkene. So you need to remember the reaction. Okay, how can you change an alcohol to alkene? Alright, so let's look back at this table here. Okay, so alcohol to alkene, the reaction is dehydration. Okay, you must know the name of the reaction. Okay, and then they will ask you to write a chemical equation for the reaction. So C4H9 OH. Okay, dehydration meaning I remove water. Okay, so I'm going to get my alkene here, C4H8, and then since I remove water, right, so water will come up. Okay, now important thing is you must put the condition here, heat, and then here you're going to put the name of your catalyst. So in this case we are using porcelain chips, okay, which is this one. Okay, so that is how you write the chemical equation. Okay, of course you need to check whether your equation is balanced. Alright, so in this case it's already balanced. Okay, and then they will ask you to draw up the apparatus. So that's why I say it's important that you identify the apparatus, the setup, okay, for the what they call dehydrations and also the oxidation reactions. Okay, reactions that has the setup, you must remember how to draw. They will ask you to sketch out in your exam. Okay, so that is how. So that is the answer lah. Alright, next they will ask you to draw is structural formula, okay, for R, and then circle the functional group. So R is a carboxylic acid, so CH3COOH. So two carbon carboxylic acids. This one is ethanoic acid, right? So first we draw the carbons, COOH. Okay, then only I fill in the hydrogens. Alright, so this is the structural formula for ethanoic acid, Kr. Circle the functional group. Okay, remember your functional group is this one, COOH. Okay, alright, general formula for acid, carboxylic acid. So you need to remember CN, H2N plus 1, and then COOH. Okay, so this is the general formula. Alright, okay, another compound S is in the same homologular series, meaning this is also a carboxylic acid. Okay, but they have 5 carbon. Write the molecular formula for S. Okay, now remember, I've been mentioning this many times throughout my videos. Okay, 5 carbon, you do not put 5 here. Why? Because you need to consider the carbon here as well. So they have 5 carbon, right? Okay, meaning you need to minus off this one. So here will become C4 and then H9. Okay, so the correct chemical formula will be C4 H9 COOH. Okay, so remember for carboxylic acids, you have a carbon at the end. So always remember to take into consideration when you write the molecular formula or the chemical formula. Okay, if they say have 5 carbon atoms, alright, it's including this one. So 4 plus 1 is 5. Okay, I've seen a lot of students making the same mistake. They put 5 here straight away. C5 and then H11COOH. So it's wrong, right? It's already become 6 carbons. Okay, so be very careful when you write that. Okay, isomerism. Okay, remember isomers meaning that so I just write the key point. You have the same molecular formula or chemical formula, but different structural formula. Alright, same molecular formula, but different structural formula. Okay, so normally when they ask about isomers, I know that they're going to ask me to draw. Okay, so you see, alright, it's always related. Okay, draw the structural formula for compound P. Okay, name all isomers using IUPAC. Okay, so compound P is the alkene, right? 4 carbon, butene. So let's draw out the isomers. Now remember, I teach you, you draw the straight chain first, 4 carbon. Okay, and then you put the double bond at the first carbon. Alright, so this one is your first structure, okay, your first isomer. Okay, so this, the name will be, since my double bond is at the first carbon, so it's 1-butene. Okay, and then remember, we shift the double bond. Okay, we shift the double bond first. So I'm going to shift the double bond to the second carbon. Okay, and then we are going to see whether it's same or different. Okay, alright, so fill in hydrogens. Okay, done. Okay, so now my what we call carbon atom, not carbon atom, my double bond is at the second carbon. Okay, so this is called 2-butene. Okay, so this is your second isomer. Alright, now if you shift the double bond again, okay, this one will be the same as the first carbon or the first butene or 1-butene. Alright, so meaning I can no longer shift the double bond. So once you can no longer shift the double bond, you are going to reduce your longest carbon chain. So from 4 carbon chain, you're going to change it into 3. Alright, so that is normally how I draw my isomers. Okay, step by step. Right, so 3 carbons and then another carbon I put it in the middle so that it becomes a side group. Right, so this one is HHH and then your double bond, you can put it here. Okay, this is already 4 bonds. 1, 2, 3, 4. Alright, so 1, 2, 3, 4. Okay, alright. Then we put numbers, okay? The one with the functional group gets the smallest number. Okay, so remember, functional group must always get smallest number, then only you consider your side group. Okay, so this one is side. Alright, so one carbon side group is called methyl at the second position. So it's 2-methyl. Okay, and then this is 1, 2, 3. Longest chain is 3 carbon. Propene, right? So 1 propene. Okay, so this is the name of this isomer. Okay, so that is how you draw your isomers. Alright. Okay, next, compound Q. This is the alcohol, right? Okay, added into this one. Okay, so you need to remember that when they say when they add it with the what they call oxidizing agent, okay, you need to remember the reactions for all homologous series. Alright, Q is alcohol. Okay, alcohol, if you react with an oxidizing agent, okay, this is an oxidation reaction. Okay, so remember, this is an oxidizing agent. Right, state one observation. So that's why I say you need to know the color change. So for potassium dichromate, okay, the color change is from orange, what do you call orange potassium dichromate solution. Okay, turns right green. Okay, so remember the color change. Right, if it's what they call potassium manganate, it's from purple to colorless. Okay, write a chemical reaction, chemical equation. Okay, so it's a C4H9OH. Remember, when oxidation, we just put a bracket and then oxygen inside. Okay, and then you are going to get carboxylic acid, 4 carbon. So you are changing from a butanol to butanoic acid. So C3H7COOH. Okay, 4 carbons. Alright, then water. Okay, so you need to balance out your what they call equation. Okay, so here we are just going to put 2 here. Alright, so it's already balanced. Technically, it will always be 2. Okay, so here I have 10 hydrogens. Okay, here I have 7 plus 1, 8 plus 2, so it's 10 hydrogens as well. So that is the chemical equation for the reaction. Okay, next, undergoes combustion. Okay, so remember, alcohol undergoes combustion. Okay, So write a chemical equation for the complete combustion of alcohol. So if it's complete combustion, meaning you will get carbon dioxide and water. Okay, so oxygen, right? And then you get carbon dioxide and water. Okay, and then you balance the carbon first. Remember your steps, right? You balance carbon first, you throw. Okay, carbon first, hydrogen next, and then only oxygen. So 4 carbons here. Here I'm going to put 4. Next is hydrogen. Here I have 10 hydrogens. Here I'm going to put 5. 5 multiplied 2 is 10. And then we check the oxygen. Here, we check this side, okay? Here I have 8 plus 5 is 13. Okay, so remember the method I taught you, 13, alright, minus 1, 12. So meaning here I need to put 6. Okay, so 6 times 2, 12, plus 1 is 13. Alright, so for alcohol, you need to remember that you need to minus off the oxygen here before you know the value here. Okay, and then calculation, alright. So this one is in your form 4. Okay, you should know how to do calculations. Okay, first step, always calculate number of moles, and then based on the equation, find your ratio, and then calculate what they want. Alright, so compound Q undergoes complete combustion, calculate the volume of carbon dioxide gas released. Okay, so first we calculate the number of mole. Now, since they give me the mass of the alcohol, right? Okay, so I'm going to use this 7.4 divided by molar mass. Okay, mass divided by molar mass. So C4H9OH, okay, butanol, okay, the molar mass is 74. Right, so I'm just going to take my calculator and then I'm going to calculate this. Okay, so 7.4 divided by 74, you get 0.1 mole. Okay, now, okay, so this is between the compound Q, meaning your alcohol, and carbon dioxide, right? So the ratio that we're going to take is between the butanol and the carbon dioxide. So you always write this in your exam. Based on the equation, okay, so 1 mole of butanol is equivalent to 4 moles of carbon dioxide. Okay, so that is how we take the ratio, okay, between what you already calculated in the first step and what they want. Therefore we use 3 dots. So if this one is 0.1 mole, okay, since the ratio is 4 times, right, 1 to 4, so this one multiply 4, multiply 0.1, so this one is 0.4 mole. Okay, now once you have the number of moles of your carbon dioxide, you can calculate your volume. Okay, so remember your number of mole carbon dioxide is equals to, alright, volume divided by the molar volume. Molar volume is always given. Okay, so in this case is 24 dm cube. Alright, so you just take this and multiply this, you will get your volume. Right, multiply 0.4. So the answer will be 9.6, but remember this is in dm cube. Okay, decimeter cube. If you are required to convert to centimeter cube, then you convert to centimeter cube. Okay, but technically that is how you do your calculation. Okay, it's a revision of your form 4. Alright, if you don't know, if you're still not sure how to do the calculation, you really need to revise back. Okay, so that's it. Alright, that is normally how they will ask questions in your SPM. Okay, they are going to combine everything. Okay, another example is something like this. Alright, and then they will ask you to name the reactions. Okay, So for example here, propene to propane, this one is called hydrogenation, sorry. Okay, hydrogenation. And then from alcohol to alkene is dehydration. And then this is oxidation. And then this one, alcohol react with acid, with sulfuric acid as your catalyst. So this is esterification. Okay, so you need to know the whole story in order to answer the questions. Alright, okay, so that's it for today. So hopefully this part here will give you a little insight on how to answer questions regarding carbon compounds. Okay, we are going to link everything together. Alright, so that will be it for today. Alright, see you next time. Bye.